Okay, so next week is the midterm exam. The material we finished today will be the last that's on the midterm. Um, so the midterm will be cover all the different topics we did in the first chapter, second chapter. It is during class. It will be on Wednesday. So if you're wondering which day next week. Um, correct. Yeah, it's a proctored. They require a certain percent of your test be proctored. I think it's 40% actually. So that's why the midterms 20 and the finals 20. So that accounts for the 40%. That's why the regular test I can just have you take it home because not corrections, but you do get to use your what did I tell you? 1 page of notes, 2 page? How many you want? 4? Okay, 4 pages of notes, fine. Open note is worse because people don't study for them. But it still allows you to plan. What do I need to put on it and so forth. You can put examples, formulas. I don't care. I'm not going to look at it. Just make sure you don't have more than 4 pieces of paper so I can visually look to see you're covered. I'm not being nice or anything like that. If you're clever, the TA3, TA4, there's at least a TA4. You can download a notepad program where you can type in everything from the book into your notepad as much as memory allows on TA4. So this equalizes the playing field because I guarantee it's a lot easier to write on a piece of paper than it is to type it into the calculator. Okay. 2.7. Inverse functions. First, we're going to cover some definitions. Remember, we had our definition of a function. For every x, there's only one y. That's still true, but we have something called a one-to-one function. And it says for every x, there is only one y, and for every y, there is only one x. So it goes both directions. Okay, bring a pop. This is going to be a bad class. Now that's a hard definition to work with. So an easier definition of a one-to-one function says if you have any of the following, it is not a one-to-one function. You can't have even powers. You can't have absolute values. And you can't have the plus or minus symbol. There's actually a little bit more than that, but those are the three that we'll really focus on in this class. Now we had the vertical line test to tell us whether something's a function, and that still applies. But sometimes you'll be given a graph like this right here, and we want to determine if it's a one-to-one function. Well, the vertical line test still applies. If any vertical line intersects at 2 or more places, it's not a function. But we have a horizontal line test that says if any horizontal line intersects at 2 or more places, it is not one-to-one. Now, it still might be a function, but it's not a one-to-one function. So the vertical line test tests the function part. The horizontal checks to make sure it's a one-to-one function. And if a graph is 1-to-1, then it has an inverse. And another note, sometimes a condition is put on the function, the equation, I should say. This function is put on the equation. Function. Sometimes a condition is put on the function to make it 1-to-1. Example of that would be y is equal to x squared. The fact we have an even power means that it would not be 1-to-1 function. It would not have an inverse. But they'll put a condition on there saying where x is greater than or equal to 0. I was trying to debate whether you'd ever have something that would have a condition on it that wouldn't be a function that fail a vertical line test. I suppose you could, but I've never seen that in the algebra book. So it's always, they give you a function, and then they make it 1-to-1 by putting a condition on it. Okay, so if I look at this problem here. And the question is, which graphs represent functions that have inverse functions? So they're wondering if it represents an inverse function. Or that have inverse functions, I should say. Well, it's a function. The question is whether I can draw a horizontal line that intersects in 2 or more places. No matter where I draw my horizontal line, the most it will ever intersect is in one place. You might say, well, what about if you draw it right here? Doesn't it intersect in many places? Well, if I zoomed in, we would see that it's not a straight line. It's still got a curve. So actually, there's no place I can draw a horizontal line where it intersects in 2 or more places, which would imply that this is 1-to-1. So the answer is yes, it has an inverse function. Now this problem, if I try to draw a horizontal line right here, you see it intersects in 2 or more places, which means it's not 1-to-1. So that means that there's no inverse. So the answer there is no. Now this next problem revolves around what is, it says use graph of f to draw the graph of its inverse function. But what this really addresses is what is the inverse? And we first look at it graphically. You know, it'd probably be better if I didn't try to do it that way. I obviously can't draw very well. Okay, so this is our original function. This is f, and it's got a point here. That point would be -4, 0. It's got a point here, which would be -1, 1. And it's got a point right here, which would be 1, 4. This is the line y is equal to x. Inverses are symmetric to y is equal to x. What that means point-wise is if this point is -4, 0, for my inverse, I'm going to have a point 0, -4. My x and y flips on my point. This point here, -1, 1, I would have 1, -1. Again, the x and y part of your point flips. This point, which is 1, 4, I would have 4, 1. Same thing, the x and y of your point flips. Now, if I drew these, or drew lines on them, I guess I should say, this would be our inverse. There's two ways you can do that. You can do it with points, like I just showed you, or you can visualize it. If you're kind of a visual person, you can take that graph, flip it, reflect it across the line y is equal to x, and get this part right here. It doesn't have to be perfect anyway, so it doesn't matter which way you do it. But that's what an inverse means graphically. Pretty good with it? Now let's take a look at algebraically what it means. F and G are functions. F and G are inverses if F and composition of F and G is equal to X. And composition G and F is equal to X. And we saw that last time. That's where you take the composition, go in both directions, and it gives you X in both of them. That means that they're inverses algebraic. Okay, so let's take a look at this problem. The instructions are to find f of g and g of f and determine whether each pair of functions f and g are inverses of each other. Okay, so number 4, we got f of x is equal to 9x minus 1. And g of x is equal to x plus 1 over 9. We'll first find a composition of f and g, which is f of g. And remember this from last time, we're going to take our f of x, which is 9x minus 1, and we replace our x with a set of parentheses. And then we want to plug in the other function inside those parentheses. So we're going to plug g in, but g is equal to x plus 1 over 9. Then you simplify it, and you see if it can give you x. Well, the 9's cancel, so I got x plus 1 minus 1, and then the 1's cancel, and that gives us x. So that's the first part. That's good. It should give us x. If they're inverses. Now go in the other direction. We want to find the composition g and f, which is g of f. Now I'm going to take my g of x, which is x plus 1 over 9, and I'll replace my x with a set of parentheses. We're evaluating, so we're going to plug f in there, but f is equal to 9x minus 1. And then you try to simplify that to see if it gives you x. And notice negative 1 plus 1 cancels, so I got 9x over 9. The 9's cancel, and I'm left with x. Now, since both of them give you x, the answer is yes, they are inverses of each other. Now 5, we've got f of x is equal to 5x minus 2, and g of x is equal to x plus 5 over 2. Same instructions. We want to determine if they're inverses of each other. So I'll find a composition of f and g, which is f of g. So we're going to take our f of x, which is 5x minus 2, and where my x is, I put a set of parentheses. We're evaluating, we're finding f of g, so we're going to plug g in there, but g is equal to x plus 5 over 2. Then we're going to proceed to simplify that. 5 times x is 5x, 5 times 5 is 25 over 2. I'll rewrite the 2 as 2 over 1. So I got 5x plus 25 over 2 minus 4 over 2, multiply top and bottom by 2. That gives us 5x plus 21. At some point, you're going to realize it's never going to simplify and give you x. So at the point where you realize it's never going to simplify, never going to give you x, you can stop right there and say, no, they're not inverses of each other. I probably would have stopped right here. I'd see there's no way that's going to give you an x. Questions on how to determine if two functions are inverses algebraically?
So you don't have to do the other one if the one doesn't work, the other one won't work either?
It might, but it doesn't matter because they both have to be equal x. So if one fails, you can stop right there. Now these next problems ask you to find the inverse. So you're given a function, and then it says find the inverse. Finding the inverse of a function. Note the function f of x must be 1-to-1. If it's not 1-to-1, it doesn't have an inverse, you shouldn't even be working the problem. Way back when I first started teaching, about 25 years ago, I was working a problem finding the inverse, and had whiteboards clear across the room. I started at one end, I was working the problem, and I got clear down to the other end. I'm looking back at this problem, I think this is the hardest problem I've ever seen in my entire life. I came up with an answer, but then I realized that the function was not even 1-to-1. I shouldn't even been working it. It was a trick one they threw in. So I always make sure I put that note there. Now everything in this course is 1-to-1, so you don't have to worry about that. If I ask you to find the inverse, it's got an inverse. Step 1. Replace f of x with y. Step 2, interchange x and y. Swap them. Step 3, solve for y. Step 4, replace y with our inverse notation. The inverse notation looks like this. Looks like the f to the -1 power. That's not the -1 power. That's our inverse notation. How you read that is that says the inverse of f of x. In step 5, if necessary, use the graph to figure out how to make it 1-to-1. Sometimes after you get done solving it, you'll end up something that is not 1-to-1. Remember, no even powers, absolute value, or plus or minus symbol. That's what I mean by we got to figure out how to make it 1-to-1.
The test next class period?
No.
Is it the Wednesday after?
Wednesday after. So week from Wednesday. Okay. Let's take a look at this problem then. F of x is equal to 5x minus 3. Now I'm going to say them, I won't keep flipping back and forth, but I'm just going through these 5 steps right here. So step 1, replace f of x with y. So y is equal to 5x minus 3. Step 2, interchange x and y, swap them. So where the y is, you put an x, where the x is, you put a y. So that becomes x equals 5y minus 3. Step 3 is a hard step. I want to solve for y. This one's not too bad. This is our, if you remember our sets for solving a formula, where you got 2 or more variables. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with y on one side, everything else on the other side. So I take -3 over. Comes a +3. last step in solving a formula-based problem was to divide both sides by what's in front of / back of the variable you're solving for. We got a 5 here, so I divide everything by 5. And while I'm doing it, these 5's cancel. I got y, but I want to put my inverse notation in there. So inverse is equal to 1/5 x plus 3/5. And that'd be your answer. Now number 7. I want to find inverse this. F of x is equal to x plus 3, the 3rd power, minus 2. Step 1. Replace f of x with y. So I got y is equal to x plus 3 to the 3rd power minus 2. Step 2, interchange x and y, swap them. So we got x is equal to y plus 3 to the 3rd power minus 2. Again, step 3 is the hard step because you use a variety of techniques to solve for y. In this case, this -2 I'll bring over, becomes a plus 2. And this I can rewrite as 3 over 1. So this is where you have a single fractional power. Now, our steps for solving this said that I'm going to take both sides to a reciprocal of this power. So I'll take both sides to 1/3 power. Now, if you remember those, we had to put a plus or minus on some of them. If you have an odd number on top, that means no plus or minus. If this had been a 4th power here, y plus 3 to the 4th power, we would have had to put a plus or minus on the other side. Now the 3's cancel here, the 1's cancel, and you get y plus 3. We know the 1/3 power is the cube root. That's what they often teach you in earlier algebra classes. They just say take cube root of both sides, which works, but the reason why you don't have to put plus or minus is because of the odd here. Okay, take 3 over gives you -3 plus cube root of x plus 2 equals y. And then step 4, put your inverse notation there. The inverse of f is equal to -3 plus the cube root of x plus 2. Now I'm not going to do step 5 yet because I don't got even powers, I don't got the plus or minus symbol, I don't got absolute values. So I've been ignoring step 5 because I haven't run across a problem yet for it. Okay, it did change. Guess I was already zoomed in. Okay, let's take a look at this one. The midterm I come up with, so if you think the midterm stinks, you can definitely blame me, because that's my doing. The final exam, somebody in our department comes up with it every semester. And I used to be involved with that when I taught math full time, but since I'm teaching like part time now, I haven't had to come with the final for quite a while, so that's good. I put this on the final exam one semester, and I think every student across the entire college missed it. It's kind of a challenging problem. Even my students missed it. I told them that type is going to be on the final. Every instructor contacted me. They said, "Don't do that again. Don't put that on the final." This is usually the type that, if it does appear in the final, this is usually the type they choose. This is the type I usually pick for the test. Of course, it's a new test bank, so I have to see what they have. But yeah, these remaining ones are just too hard for tests or for finals.
Yeah. Is it on that same website as the chapter test?
There is a final exam review out there. If you go to Math Heals, you'll see a link for final exam reviews, and you'll see, like, I think 3 copies out there. Okay. Number 8. Okay, step 1. Replace f of x with y. So we've got y is equal to 4x minus 1 over x plus 5. Step 2 is interchange x and y, swap them. So where your y is, you put an x. Where your x is, you put a y. Again, step 3 is your easy or your hard step, solving for y. Now this is a formula type. You got the equation that equals, and you got 2 or more different variables. So I want to solve for y. Our first step, you were in parentheses, don't have any. Second step, you were in fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so that's our LCM. So we'll multiply both sides by y plus 5. So that gives us xy plus 5x equals, and these y plus 5's cancel over here and gives us 4y minus 1. Our third step in solving a formula for a variable is to get everything with the variable we're solving for on one side, everything else on the other side. So I'll take 4y, move it over, and I'll take 5x and move it over. So you got xy minus 4y equals negative 5x minus 1. Our next step in solving a formula for a variable is that if you have 2 or more y's, you want to factor it out. So we'll factor out a y, and that leaves us x minus 4. That's great. High schools probably aren't hearing me at all, and people at home. But I'm recording it. Zoom's having some issues, or at least it is with my account. Okay, last step. Divide both sides by what's in front of / behind the variable you're solving for. There's an x minus 4 after it, so I divide both sides by x minus 4. Now, step 4 says replace y with your inverse notation. Internet crashed. That would prevent Zoom from working, or our connection to the internet crashed. If the internet actually crashed, what do you think that means? Probably we're in nuclear war, so go ahead and say your prayers. You're done. The flames will be coming and melting us all soon. The way the internet's set up, if you just have like one segment of it down, for the whole internet to be down means something huge like a nuclear war. They actually designed it for nuclear war, as weird as that seems. Because if a nuclear bomb hit like Chicago, wiped out Chicago, how would these other places still communicate? Like if everything went through Chicago and you wiped out Chicago, communication would be dead. So the way it's the networked out, Chicago can go, Dallas can go, and it still works. Now they put something additional on here, and they'll say x cannot equal to 4. They don't put that on there to make it 1-to-1. The fact it doesn't have an even power, doesn't have absolute value, doesn't have a plus or minus symbol, that's what makes it 1-to-1. They put it on there to specify the domain. Our connection to the internet couldn't go down on Thursday when all my classes were via Zoom, so I could just go home. Okay. Let's take a look at this problem. I could, but I like to do it. I'd prefer just do it at home. You can tell our internet connection crashed here. It's small things, but my Australian shepherds come in for lovin's when I'm teaching at home, so they just want to be petted. One, she just kept coming in last night. She just finally there was nobody on. I was doing online office hours for my computer science courses. I finally went and asked my wife. I said, "Have you fed these dogs?" So she doesn't usually come in and want that much lovin's. Okay. Now, same instructions. Find the inverse. Normally, since it had an even power, we wouldn't even try to work the problem. But they put a condition on here. And we're going to see when we graph this later, that condition makes it 1-to-1. Okay, step 1. Replace f of x with y. Step 2, interchange x and y. So we've got x is equal to y squared plus 2. Step 3 is solve for y. Here we got a second power, so I'm going to take the 2 over. And we're going to use the square root property. That's what I said. Every problem has a different technique for solving for y. Whenever you have something squared equal to something else, you drop your squared, and you put a plus or minus square root on the other side. So interestingly enough, as I'm writing, it actually is appearing on the screen here. So Zoom is slowing it way down. Yeah, step 4, put our inverse notation in there. That's when my handwriting looks worse than it normally does. It's like got that lag. Now we got a problem because we got the plus or minus symbol here. We can't have that. That's not 1-to-1. So if we look at our graphs, X squared plus 2. Well, x squared is a U-shaped graph. And the plus 2 means it's been shifted up 2 units. So we got our graph looks like that. Now they say x is less than or equal to 0. What that means is we want to keep the part of the graph where x is less than or equal to 0. Which, connect the dots, would look like that. By not having this side, it now passes the horizontal line test, which means it's 1-to-1. So that's what that condition does. Okay, now remember, it's symmetric about this line y is equal to x. And I'm just going to eyeball it and flip it. Remember, symmetric means you can flip it, reflect it across that line. So this right here would be our inverse. Now, if I backed up one step, this right here says y equals plus or minus something. If I look at the y down here, where this inverse exists, is it positive or negative down there? It's negative. So that's where my negative values are, which means what I'll keep is I'll keep the negative. Whenever you have the plus or minus symbol, you'll either keep the positive or negative. And looking at your graph is probably the easiest way to decide which part to keep. Now, they'll put something additional on there. They'll say x is greater than or equal to 2. This has nothing to do with making it 1-to-1. When you got the plus or minus, either getting rid of the plus or minus is what makes it 1-to-1. This is specified in the domain. Don't stress about these too much. Like I say, you never see them on test, never see them on final exam or midterm or anything like that. Why do I even cover them then? I wouldn't, except for if you're going on to trig. I think there's one person going into physical therapy in here. You have to take trig, and you see a lot of this in trig. So there's a reason why I keep stuff. Let's take a look at this problem. Let's see. Back on up, get rid of the paint bucket. There it goes. Yeah, there's one topic I've taken out completely from the course, except for I teach this online, and I'll have students ask me about it, called the difference quotient. It's like f of x plus h minus f of x over h. And I probably should leave it in because you use it in calculus, but you covered enough in calculus that I don't really worry about it too much. Yeah, it's back up. Look at that. Of course, nobody's on now. So probably doesn't do me good to connect it. But I'll go do it anyway, just in case. Maybe not. Boy, that's slow. My little face should be popping up here. Okay. Step 1. Replace f of x with y. So we've got y is equal to square root of x minus 3. Step 2, replace interchange x and y, swap them. So replace y with x, replace x with y. Step 3, solve for y. You have to take negative 3 over, it becomes a positive 3. This is a radical equation, and steps for solving a radical equation: get the radical by itself, raise both sides to a power equal to the index, which in this case is squaring both sides. So we end up with x plus 3 squared equals y. Step 4, put our inverse notation in. Now step 5 is we got an even power. You can't have an even power for an inverse, so we need to graph this and see what's going on. F of x is equal to square root of x minus 3. We know what square root of x looks like. It kind of goes off like that. The minus 3 means it's been shifted down 3. So that right there would be our function. Inverses are symmetric to this line y is equal to x. So if I flip that across there, this would be our inverse. Now that's what we want. Let's see what we got. X plus 3 squared. We know what x squared is. That's that parabola. That's the U-shaped graph. The plus 3 is inside with the x. That means it's shifted left or right, opposite what you think. Plus 3 make you think right 3. So it's really shifted left 3 places. And looks like that. Now this is what we got. This is what we want. If you look at that, that looks like the right side of this graph, doesn't it? And this is negative 3, so I want to put a condition on here. I want to say where x is greater than or equal to negative 3, and that'll specify the right side of my graph. So again, by looking at your graph, that helps you figure out what to do on it. Pretty much anytime you have an even power, you're going to put like x is greater than or equal to some value, or less than or equal to, as appropriate. Questions on any of those? No. No, it'll be on paper. Yeah, so you don't have to worry about bringing the computer or anything. Yes. So it's not right or wrong. I'll grade based upon your work. So each problem's worth 10 points always. If you do all of your work right, but you just mess up one little sign, then you'll miss probably about 2 points. So if you leave a blank, that's where you get minus 10, or you just have no clue how to work a problem. Then that's, you know. But pretty much, I'm pretty easy going on grading.
So if you expense the problem, you're going to get some credit even if you don't do it.
Right. Now the final's not that way. So, and the average grade on the final exam, it's multiple choice. You take multiple choice, you do better, right?
Yeah.
But it's along the same principle. You know, if you make one little mistake, you get the different answer, and then everything's wrong on it. So I don't grade work based upon for the final exam. It's because we have to have grades in so fast. But midterm, if it takes me a week, 2 weeks to grade it, then I can grade your individual work. Finals, when I have to have like grades in the next day, it's like, oh, that's not possible. The average grade on the final exam is about 60%. You'd be shocked at how much you forget from the beginning of the semester. 16 weeks, and this is like, did we even talk about this? So now this is section 2.8, distance and midpoint formulas, circles. Now our distance formula says given 2 points, x1, y1, x2, y2, distance is equal to square root of y2 minus y1 squared plus x2 minus x1 squared. A lot of people just say, I don't know why I need to take college algebra, I'll never use it. Is that a true statement? No. Many of you will use it millions of times per day. That's how much algebra encompasses your life. If you ever watched a YouTube video, TikTok video, you watch TV, for that video transmission to go through in the original format, it'd be so huge you'd never receive it. So what they do is they compress it. Basically, they transform the signal so they can send it through whatever wire, over the air, whatever it is. And on the receiving end, your phone, your computer, your little cable box from Cox, your TV, reintegrates it into the signal. Now, how they transform it is they use something called logs, which we'll see in chapter 4. And as it's sitting there doing it over and over, if you told me it's doing a couple million transformations so you can watch an hour video, wouldn't surprise me. The distance formula. If you play video games at all, if you play games on your phone, you get bored, you start playing in class even. It's constantly checking the distance. Like if you got something dropping from the top, like a block, and you're trying to line it up with another color or something like that, whatever the game might be. The reason why it stops is because it's checking the distance between it and blocks that are already there. So for each game cycle, which there's a lot of game cycles when you play a game, it's checking the distance for all those different objects. So you'd be shocked, but you're using algebra millions of times per day. Now, are you going to calculate it? No, but you're using it millions of times. So. Now, if you go home and you don't watch TV and you don't watch TikTok or YouTube, but you don't play video games, and you read by candlelight, you're probably not using algebra. So, okay. So let's take a look at this problem. We got 3, -5, 9, -7. And want to find distance between them. Now this is my first point, so I'll label this as x1, y1. This is my second point, so I'll label this as x2, y2. If you mess up on signs, this is especially important. But I'm going to go through and I'm going to replace my variables with sets of parentheses. I'll make them a little smaller so I can separate the two. If you don't mess up on signs, this isn't as important to do. Remember, this is our y2, this is y1, this is x2, and this is x1. Then you plug in the values. We put -7 for the y2. We put -5 for the y1. For the x2, we put 9, and for x1, we put 3. Here we got negative, so we got -7 plus 5 squared. And here I got 9 minus 3, which is 6 squared. Negative 7 plus 5 is negative 2 squared. 6 squared is 36. Negative 2 squared is 4 plus 36 gives us square root of 40. Now, I'm not going to actually type these in a calculator. You can if you need to practice pushing your square root button. But I'm going to show how to simplify them. You have to do the prime factorization of 40, which is 2, 4, 8 times 5. Remember, the square root, we're looking for a pair of somethings. Here's a pair of 2's. So a pair of 2's is going to come out. And we're left with 2 times 5 inside, which is 10. And that's our answer. Oh, by the way, even if you're playing a 3D game, it's constantly checking distance. I like to play Call of Duty online. So you're running around shooting at people. You know, the bullet passes by their 3D head. It's checking the distance between those objects. Yeah, if you enjoy any of those things, you gotta love algebra. You may hate doing algebra, calculating, but you gotta love algebra. What gives us fun things in life? I haven't for a while. I probably haven't played for 3 or 4 months. I get busy with work and then I don't do it. Which is probably just as well because I become engrossed in it. I'll be sitting there for 4 or 5 hours playing Call of Duty. And I don't know why. My wife doesn't appreciate my. I don't do anything around the house anyway, so she, me working on computer stuff, she usually likes that better than doing nothing. Okay, same instructions. Find distance. This is my first point, so I'll label that as x1, y1. This is my second point, so I'll label that as x2, y2. And again, if you mess up on signs, it's a good idea to go through and replace those variables with sets of parentheses. You can use a lot less parentheses if you don't mess up on signs. Okay, so y2 is 4 square root of 5. y1 is 2 square root of 5. x2 is negative square root of 2. And x1 is 3 square root of 2. Now, whenever your square roots are the same, and you're adding and subtracting, you add and subtract the numbers in front of them. 4 minus 2 gives us 2 square root of 5 squared. Over here, we got negative 1, invisible 1, and a negative 3. That gives us negative 4 square root of 2. Now, if everything inside of your parentheses is multiplication, and you raise it to a power, you can take everything separately to that power. So take 2 to the second power and square root of 5 to the second power. Take negative 4 to the second power and the square root of 2 to the second power. Two squared is 4. And when I square a square root, they cancel, so that gives me 5. Plus negative 4 squared is 16, and square root of 2 gives me 2. So that gives us 20 plus 32, which is 52. And you always want to simplify your radical. 2 times 26. 26 is 2 times 13. We're looking for a pair of somethings. Here's a pair of 2s, so a pair of 2s comes out. And our answer is 2 square root of 13. Oh, make sure you keep your distance, like 6 feet. Yeah, our president of the college really emphasized that last week. I guess Independence Community College has it spread through so bad through their student body. They're still doing everything online. They think they'll open next week, but they haven't made a decision yet. Butler, I think, has about the same shape as Cali. We're not. I think. Well, they won't tell us how many cases. And I'm wondering myself how many there are, because the president said, well, there's not a whole lot of cases, and that may be like relative to some of these other places. But there's one. Our union sent out an email asking how many students you have that are infected with it, the count. And one person came back with 5, and that in her classes that were infected with it. So I was like, wow. As far as I know, I don't have any. Okay, now the next topic is the midpoint. Oops, not if. Sorry, I was thinking about the election. Given 2 points, x1, y1, x2, y2. Midpoint is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. May seem like a weird thing as I'm writing down a math topic to see I'm thinking about the election. But my wife and me were talking about that. Joe Biden claimed that if he gets elected, he'll cure the coronavirus. And my wife said, yeah, listen to the crap he's saying type of deal. And I said, I believe it. She's looking at me and said, what do you mean? He won't, he doesn't know any medical stuff and so forth. And I said, I believe it. Once after the election's done, you won't hear anything about the coronavirus anymore. I said, he'll cure it. Of course, if Trump wins and the media go crazy, and you'll probably hear about the coronavirus quadrupling and everything. Let's see. Okay, let's take a look at this problem. Now, this is my first point, so this will be x1, y1. This is our second point, so that'll be x2, y2. Now, really, there's no need to put extra parentheses here. Hardly anybody messes up on signs on the midpoint formula. You're just adding the x's together. So we've got -5, -3 divided by 2. And you're adding together your y's. So -9, -4 divided by 2. -5, -3 is -8 divided by 2. -9, -4 is -13 divided by 2. That gives us -4 and -13/2. I'm kind of upset because I got to work tomorrow night. I'm going to miss the debate. It's tomorrow night. I should cancel class, I guess. I don't know. Yeah. Even better in the debate would be the Saturday Night Live, because I love how they make fun of Trump. When really they should be making fun of both of them, because both of them are so humorous. And Biden's like me; he forgets, barely remembers his name and so forth. And Trump, who's that guy that play Trump in Saturday Night Live? Alec Baldwin? Yeah, he does that so good with the face. And don't get me wrong, I like Trump, but it just kills me when they make fun of him on Saturday Night Live. Yeah, that's pretty sad.
Still like 2 other people, but everyone's focused on Trump and Biden. There's so much bad publicity.
Yeah.
They think that's the choices.
Yeah, it's there was a lot of Democratic candidates who were pretty good that fell by the wayside, I thought. I actually like Kamala Harris. You know, she's kind of weird on some of her, you know, the time she made up about smoking marijuana, and while she was listening to the song that hadn't come out to like 5 years after. She did an interview. She was trying to, but you know, she seems very, you know, competent on the ball. So, you know, I don't think it'll affect me either way, whoever wins, because I don't think Biden's competent enough to actually be president for very long. So then Kamala Harris would step in, and I think she is quite competent. Okay, I digress. 40. That's 2, 4, 8 times 5. You always want to simplify radicals before you go on. Here's a pair of 2s, so that's going to come out as a 2. 2 times 5 is 10. Now at this point, we're ready to find the midpoint formula. So I got 2 square root of 10 plus the square root of 10 over 2. Then I got negative 3 plus 3 over 2. That gives us 3 square root of 10 over 2. And negative 3 plus 3 is 0. 0 over 2 gives us 0. And that'd be our midpoint.